Hi everyone, today we will solve these problems, containers with most water. You are given an integer array height of length n. There's n vertical lines drawn such that the two endpoints of i's lines, these two lines are together with the x-axis from a container, such that the container contains the most water. Return the maximum amount of water a container can store. Firstly, we will need to go through an example to fully understand this. So in the example 1 in here, we have the height represents the integers array here. Each element in here is represent for the height of the columns in the graph in here. So at the first index, as is number 1, is represent for the height of the first column in here. And then 8 is represent for the second column height. And continue like that, we will have the graph like this. And we will need to calculate the maximum waters. Each of this one is contains, we will have many possible ways. In this case, we can come up with the question for the interviews like whether the height in here have all of it can be 0. What happens if all of it can be zeros? We just output 0, or we can return something, or it's not the case. So as you see in here, we have the height of it. The height at I can be 0. X will be smaller than 10 to the 4. So the height of it can be 0. So I think at that point, if all of it is 0, then we can just return 0. And we can have another question for the interviewers like the height in here can it just have like empty array? So in that case, we will return 0 as well. In here, we can see that the n in here is larger or equal to 2. So the array height in here is not empty. It have at least 2 elements in that. Whether the height in here have the negative number. And we also know that in this case, it is larger or equal to 0. So it cannot have the negative number. Okay, I think that is all the questions that you should ask the interviewers. I think we understand these problems. So next we will move on to planning and matching step. So currently we are having the example 1 in here. So I also draw the graph to represent example 1 here. We can do 2 pointer approach. So maybe we have left pointer here. So left pointers, and this one is the right pointer. So once we have that, we will calculate the areas between the left pointers and then the high pointers. So between the left and then the high in here, we can calculate the width between it. So this part is 1, 2, 3, 4, 5, 6, 7, 8, right? So we have the width is 8. Width is 8. And then the height should be the minimum height of the left pointer and the right pointer, right? The area should be look like this, right? So the height of it is getting the minimum between pointer left and then the pointer right. So from that, we can have the height is 1. So this one would be calculate the areas. Area of this one should be 8. We have 8 times 1, so it would be 8. So we know that this one is really small. So we will, to optimize the solutions, we will move whichever pointers have their height smaller than the other. We will need to move that pointer by 1. So in here, we have the pointer left in here, we have the height is 1, and then the right pointer have the height is 7. So we will move the left by 1. So left here. So it's point to the height of 8 right now. So next we will also calculate the width and then the height again. So the width of it. So in here, we can draw the container like this. So with that, the width should be again 1, 2, 3, 4, 5, 6, and 7. So we have the width is 7, and then the height of it is a minimum between the left pointer and then the right pointers. So we have the right here. So the right here is 7. So 7 times 7, we have 49. So with that, we also need to store the max area. So the max area is 49 at this point. And then we will move on. The right pointers is smaller than the left pointer in this case. So we will moving the right pointers by 1. So this part, the right will be point to here. And then next we will also recalculate the width and then the height. So the width of this one, we know that last time is 7, so we know that it is 6. And then the height of it. So the height of it should be, look like this. So the height of it is 3. So we have 3. 3 times 6 is 18. So if we keep doing like that, we know that this will work, and we will have max areas is 49 because we calculate all the areas between all the containers. So we will move on to the implementation step. In these steps, I will do it in Java, but I also have Python solutions in the description below, so please check it out if you're familiar with that more. So in here, we have the functions max areas. We have the max variable to store whether it is max or not, so initialize would be 0. And then we will do the two-pointer approach, so we will have the left side pointers just points to 0, index 0, and then the right side pointers will point to the index at the end of the height array that we have. So height length -1. Next we will have the while loop, and the right will be always larger than the left, right? So this we have this, and then we will calculate the width of the x-axis as we know. So the width of it will be the right minus the left, right? Once we do have that, we can easily calculate the area of that containers by doing this area here. By doing the width, we'll need to times the maximums with the mean of the height between the left and the right, right? The height of left and then the height of right. Okay. Once we calculate the areas, then we need to compare it with the max that we have to make sure it will get the maximum areas. So max with the areas that we have in here. So once we have that, we will choose if which pointer will move. So in here, we will have like if the height of the left is smaller than the height, smaller or equal to the height of the right, then we know that we will need to move the left pointers, right? So left will need to plus, and else we know that we will move the right pointers, minus here. And after doing that, we know that we will have calculated the maximum areas. So we finished with the implementation step in here. So we will look through the example to see this implementation is fully worked. And in the interface settings, you don't have the IDE like Leetcode here. So we will do this one by hand. So we have the max is 0, and then left will point to 0, and then right is at the end of height here. So we have how many? 1, 2, 3, 4, 5, 6, 7, 8, 9. So we will have 9 minus 1 is 8. So this is the index of left and right, and we go into this while loop. The width of the left and the right is 8. So the area in here would be equal to the minimum of the height and left and right here. So that is the minimum between 1 and 7. So we will have 1 times the width here. So the width is 8. So we know that the area in here would be 8. So the max we will update it to 8. And let's come to the if statement in here to move the pointers. The height of the left pointers is smaller than the height of the right pointers. So we will move the left by 1. So this one is updated to 1 here. So that means that right now we will compare the width here, which is shorter. So I just draw the width here. 7 in this case, right? It's 8 minus 1, so it was 7. And then we calculate again the areas. So we have 8 and 7 in here, and the mean of it is 7. So 7 times the width we have in here is 7. So the area is 49. With the 49, we will update the max here. And then we will come to the if statement in here, and we know that the height of the right is smaller than the height of the left. So we will do the right minus here. So the right here is smaller than is 7. So let's calculate the width again. So the width in here would be 6. And then the area in here, the minimum of 3 and 8, it will be 3. So 3 times 6, it will be 18. So with this, we know that it is not larger than max, so we keep the max. And then it will get to this part, and we know that 3 is smaller than 8, so we move the right pointers by 1. So this part will be 6. And then we come back to this statement, the width will be 5. And we calculate the area again. So with 8 and 8 in here, so the minimum is just 8. 8 times the width is 5, so it will have the area is 40. So it is not max. It is not larger than max, so we will keep the max here. And if we keep doing that until the end, we will have the max is 49. So that is how we will do these problems, and we make sure everything is working by checking this part. Okay, so we have the accepted answer. In here, we know that the time complexities of these problems will be O of n, because we will have to go through every node, but we just go through it one time with the left pointers and then the right pointers. So we have the big O of n here. And we will have the space complexities is of 1. Since we don't store any data structures, we just store in pointer. So it is of 1, constant space complexities. So with that, we will need to try to submit it to see it fully work. So we have the successful results here, and this solution is faster than 98% of on Java online submission for these problems. If you have any questions, please let me know in the comment below. I will get through that, and tell me more about the problems you want me to do next. And please like and subscribe to my channels. So thank you.